Chief.
Agent Rick, are you still following up on that case?
Yeah, I'm still on the case.
Okay, I want you at the site ASAP.
Alright, I'm about to hit over there.
Don't screw around. Keep me notified.
Yeah, Chief. Alright.
Yeah, boss?
DeLucci, do you have the last packet?
Yeah, we're about to head over to get the last bag. Somehow your prodigy had to overlook that.
Alright, well don't screw around. Keep me informed.
Yeah, we'll keep in touch, boss. Alright.
You know what? Get up.
Okay, in this problem we're going to solve for the frequency of a wave. We will do so using this equation right here, and that is the speed of the wave equals the wavelength times the frequency. Now we are given the speed of the wave, which is 330 meters per second. We are also given the wavelength, which equals 0.2 millimeters. Notice, however, that this is in millimeters, and in order to truly be able to solve this, we need to convert that into meters. And so this will actually be 0.0002 02 meters. Now we just have to plug this all in. So this will be the wavelength, this wave speed, which equals 0.330 meters. Well, not point, sorry about that. This is 330 meters per second, which equals which equals the wavelength, which is 0.0002 times f, which stands for frequency. Now what we need to do here is divide everything by 0.002, and the result will be 1,650,000 hertz. Frequency is measured in hertz, and that is the answer to this. Okay, so in order to find the period of a pendulum, we need to use the equation t equals 2 pi times the square root of length over gravity. So we are given the length of a pendulum, which is 1 meter. Now, unless told otherwise, the acceleration due to gravity of this pendulum is 9.81 meters per second squared. That is unless told otherwise. So all we need to do here is plug in the numbers, and which will be equals t equals 2 pi times the square root of 1 over 9.81 meters per second. Now first off we have to find we have to find the square root of 1 over 9.81, and that is going to equals that is going to equal 0.319. So then now all we need to do to solve the problem is multiply that times 2 pi, and we get the period, which is going to equal to 2.006 seconds. And that is how to solve for the period of a pendulum. Now we're going to solve for the spring constant using the equations for spring, which is t equals 2 pi over 2 pi times the square root of m over k, which is mass over the spring constant. We are given the mass, which is m equals 0.22 kilograms, and we are also given the period, which equals 2.24 seconds, and we are looking for the spring constant. Now what we need to do is just plug in the numbers as always, and it's going to be 0.24 is equals to 2 pi times the square root of 0.22 over k. First thing we need to do is divide everything by 2 pi. And so when we do this, we're going to get 0.038 is equal to the square root of 0.22 times over k. Next up, we need to square both sides in order to get a good answer. We square both sides and we get 0.001459 is equals to 2.22. Now, of course, you can just round up you can just round up the square root of 0.38, and it's going to be over 0.22 over k. Next, you're going to multiply both sides by k, and you're going to be left with 0.001459 times k is equal to 0.22. Then you're going to divide everything by 0.001459, and this will leave us with K equals 150.78 newtons over meters, and that is how to find the spring constant of spring.